As I said, actually I'm from South India. My full name is cannot pronounce, so you can call me Damodar. That's enough, I think. And I've been in teaching for the past 13 years. So today we are going to discuss the web AR concepts. And today's agenda is not to build AR applications, but just to give you introduction about the technologies that we can use to build web AR applications. So I'm sharing my screen with you. So I can tell you a few topics.
Yes, sir, it is visible, sir.
Yeah, good. And students, if you have any doubt, you can put me in the chat. Okay, chat window is always here. So today's agenda, what we want to discuss is, there are 5 topics that we want to discuss. One is the AR, VR. Then what is A-frame? Then we discuss ECS. Then we discuss components. And finally, we discuss how to publish, host AR, VR apps. So before we dive into the web AR, VR, so we should be knowing what is AR and VR. It's emerging technologies. Many people know nowadays we are using in day-to-day life. And you will be using the Snapchat AR or Instagram AR. Okay, there are many AR filters available in many applications. And if you go for any gaming AR, the perfect example I can give you is Pokemon Go. Pokemon Go is AR-based game. And recently, if you have read news, there are many AR games. For example, Angry Birds AR. Angry Birds AR game. It's available for both iPhone and Android. Okay, then there's one very popular Mandalorian AR. It's again a game-based AR application. It's available in Play Store. These are actually you can install and check the AR experience. Okay. And what is AR? That's the first thing that we want to discuss today is, they say it's augmented reality. Augmented reality. And before that, we have virtual reality. And nowadays people are calling mixed reality also. And even though our today's topic is more about AR, understanding these 3 technologies, the other 2 technologies like VR and AR, VR and MR will help us know in understanding more about our AR. So VR, if I put in simple words, virtual environment, virtual environment, virtual objects augmented on physical world, and finally MR, virtual objects interact with physical objects. This example for, we have a HoloLens. So from Microsoft product we have an AR, all mobile phones, maybe smartphones you can take this. And VR, you need VR headsets, mostly VR headsets. For that, if you go, the low cost option is cardboard VR. And if you want high quality, you can go for HTC Vive, or you can go for Oculus. Oculus, and there are many products from Oculus that you can try. And if you want to try very low cost VR, the Google has released cardboard based VR experiences. You need just a smartphone. It can be your iPhone or Android phone. So you'll get a very normal VR experience. And if you want very immersive, very high quality VR experience, then you should be buying some expensive headsets. There are good games available. Even a PlayStation VR is available. So PSVR is available. So you can play some PlayStation games in VR. So VR, once you wear the headset, you won't be seeing any physical world. All you will see is only the virtual environment, virtual objects. But in AR, you can see both physical as well as virtual objects through your mobile camera. So once you scan the physical environment using your AR app camera, actually we are placing the 3D objects or virtual objects on the physical world. As I said, the example is for Pokemon Go. And the best example I can give you nowadays, IKEA has its own app where you can, before purchasing any furniture from IKEA, you can actually place it in your room or house to check how it fits in your room. After that, you can order from the application. So instead of going to shop and checking the physical products, you just sit in your home, open the IKEA application. There we have lots of 3D models of the furnitures like sofa, bed, almirah, many things. You just select the 3D object, place it. You can, there is again, tap and zoom touch is available. You can place it, you can enlarge it, you can make it small. And if it is okay, then you can go for order. So IKEA is the first multinational company implemented this AR experience for the buying of furnitures. And there are many applications nowadays they are using for marketing purpose, and online stores also they are using. And one more example I can give you for Lenskart uses AR technology. So Lenskart, if you go to Lenskart, you can try the specs without buying it from the, you just need a web browser and a web camera. You need to face the camera. It will automatically puts the specs. Specs is again a 3D model on your face. And nowadays, there are lots of filters available for Instagram and Snapchat, and they are mainly using it for marketing purpose. Okay. So in here, what we are doing, we are just augmenting the virtual objects or 3D objects. It can be 2D or 3D objects in the physical world. And mixed reality, when I say mixed reality, what I say here, virtual objects interact with the physical objects. How the virtual object is going to interact with my physical object. Suppose there is a table in my office. I'm using HoloLens. In the table, I might be having one book. So any HoloLens based application can interact with the book. So how? If you think it's impossible actually. It's a physical object. I have a virtual ball. The virtual ball won't interact with the physical object directly, but using some technology, we can make it happen. So what's the technology nowadays? Even in iPhone, they have LiDAR scanner or depth scanner. So what it does, it just scans the environment for the depth points. So once the scanning is done, wherever the depth is there, it will understand there is some object. So if you roll the virtual ball, based on the depth map, it will actually interact with the environment. For the ball, it doesn't know whether it's a book or any other object. It only knows the depth map. The depth map can be created using depth sensors. And nowadays, if you see the high-end phones comes with the depth sensor, or in iPhone, we have LiDAR scanner. It just scans the entire environment to create the map. But what if we don't have the expensive depth sensors in our phone? Google has the answer. So Google's AR Core provides one depth API. For this API to work, you just need your normal RGB camera. It means any phone with normal camera can create a depth map. Based on the depth map, the virtual objects will interact with the environment. Okay, this is what they say mixed reality. And if you want, you can check the HoloLens sample videos, you will understand how it works. But in normal AR applications, you can place the virtual objects, but it won't interact with the physical world. So there will be no interaction. But if you want interaction, then you should be creating a depth map first. Based on the depth map, your objects will interact with the physical environment. And that's a small introduction about all these technologies. As I said, there are devices to experience these different kind of applications. And there are standalone VR headsets or some headsets that depend on the PC power to give the experience that we can buy and experience it. And we'll come back to our today's topic. It's all about web, AR, and VR. And all these three VR or AR, MR applications need its own device to run. If I say VR experience, it needs a VR headset. If I say AR application, it needs mobile phone. And if I say MR, you need a MR headset. Specifically, the HoloLens is the best product nowadays. So best product nowadays, you need it. So why people are nowadays going for web-based AR VR? And there are many examples I can give you how to improve your business, how to improve your marketing. See, when I say AR VR, it's not only for gaming. Gaming is just a vertical. Apart from gaming, you can use these technologies to improve your business, mostly the marketing purpose, interactive marketing. That's what we're going to see. So if you want to create a game, you can create. If you want to create a marketing campaign using AR VR, you can create. And back to the question, why people nowadays going for web-based AR? The thing is, you don't need any special hardware or software to run web-based AR VR. You just need a web browser. It can be a mobile web browser or it can be a desktop-based web browser. Most of the browsers nowadays support the web AR and VR standards. Specifically, if you take Chrome, Firefox, Safari, Opera, all these browsers supports. Nowadays, by default, every person has in their mobile phone Chrome or Safari. So we don't need to worry about the software. You just need to create the web AR or VR experience and publish. That how to publish and all we are going to see right now. Okay. Fine. So you just need a browser, and it's same like your normal website. How the website works, you just need to give an address and press enter, the website loads. For example, Amazon.com. You just give the address. Same like your AR application or VR application going to load. Okay, and for VR, still you need a headset. Okay, even though if they say web VR, you need a headset to experience the full capability. But for AR, you just need the browser. You just open the web page, it accesses your camera and does the job. Okay, and there are standards. WebXR is the standard. So using the standard, anyone can create their own web VR AR API using JavaScript. So this standard gives guidelines on how to create web VR AR frameworks or libraries. Mostly you will be using JavaScript because it's a web-based thing. There are three technologies that you should be needing here to understand web-based AR VR. First is HTML. Second is JavaScript. CSS mostly we don't be using, but the most thing is HTML you should be knowing, and JavaScript is the main scripting language used for all these web-based animations or 3D whatever. Now, as I said, initially we were using web VR experiences so that So people wanted both Web XR API. XR means extended reality. Extended reality means so nowadays we are using Web XR API. It's a standard actually. Like HTML standard. This gives guidelines on how to create web VR AR frameworks or libraries. And based on this standard, we will be having lots of tools seeing right now. This is just a standard. No need to learn all these things, but should be knowing what is standard powering all this web AR and VR. And next, what you want to know is what is web graphics and rendering. We know the normal graphics. Whenever you play a game on your computer, you need a graphics card, and the game is running on your Windows machine. But people wanted the graphics to run on the browser itself. So initial days, it's very difficult to get the heavy animations or 3D animations on the browser because there was no graphics library available for the web, specifically for web. If you take the desktop, we have different types of graphics libraries. If you take Windows, we have DirectX. If you take Linux, we have OpenGL. And nowadays, most of the Android phones, by default, Android phones support Open. See, these are graphics libraries that gives the required components to render the graphics on the screen. But initially, there was no default or any specific graphics library for the web. So then they invented WebGL. WebGL means Web Graphics Library. Again, who invented this? Whoever invented this OpenGL.
Sir, your voice is not clear, sir. Sir, your voice is not clear.
Just give me a minute. Is it okay now?
Yeah, it's okay, sir.
It's fine, sir.
Okay, fine. As I said, the WebGL is a graphics library for the web. And what is the code inside it? Mostly, you'll be getting C and JavaScript. Anything related to graphics, without C, you cannot create it. And when it comes to web, you need to port to web. Web means the only language we'll be using is here, JavaScript. And again, we are not going to check what is inside WebGL. Again, it is for the programmers, the low-level programmers who directly interact with the hardware. They might be needing this WebGL APIs. We are just knowing what is powering the graphics on the web. That is WebGL. The OpenGL group is maintaining this WebGL. Okay, that's what they say. Web graphics and rendering. As I said, anything that we want to render on the web screen, the browser, you need the graphics library that is given by the WebGL. And they say WebGL is a JavaScript API to render 2D, 3D graphics within any compatible internet browser. That is very, very important thing. And in future, you will be seeing lots of heavy games on the browser itself. Okay, nowadays we are installing it on the machine. It's a standalone game. But in future, once the 5G comes, once the platform, the powerful processor are released, maybe later in 2 to 3 years, you will be playing the heavy games on the browser itself because of web graphics. It's still in early days. There are many things they are adding every month, every year. Okay. Now, for what purpose we can use WebGL? You can use it for gaming, online gaming. You can use it. You can create games. But again, for heavy games, you can create, but you cannot expect everyone to play it because still you cannot expect everyone to have the high-speed internet connection. So again, high processing machines, that will take time. But it is possible. You can create all the powerful 3D content. The content can be animation or game or VR or AR experience. So this is the main graphics library that enables us to create anything 3D or 2D graphics. And then what is the next thing you want to know is 3.js. 3.js is again based on JavaScript. It's a JavaScript library to create GPU accelerated 3D content. See, this 3.js is very, very old. Give me a minute. I'm getting a call. Yeah, we'll continue. So 3.js is a JavaScript library. It was invented before WebGL. WebGL is a new one. 3.js is just very old technology. Before a decade, they invented this, and they created their own rendering components to render the 3D graphics. But what 3.js did after the WebGL invented, they actually implemented WebGL rendering in the 3.js. Okay, 3.js is very, very old tool, as I said. Before WebGL, it was invented, and they were creating simple 3D animations and interactive content, but they are using their own rendering component. Again, it means only the hardcore JavaScript coders will understand those kind of things. After the invention of WebGL, what these people did, 3.js developers, they included WebGL rendering component inside 3.js. It means rendering on the web is easier now because of WebGL. Again, if you want to create the 3D animations or 3D games in web, you can use 3.js. So if I go to 3.js website, you'll understand. So 3D JavaScript library. See, all these 3D content you can create. It can be a game, it can be a marketing material, anything. And see, here it is not, here you can see anywhere it is not mentioned AR, VR. AR, VR is different. You need the WebXR standard to implement it. We'll come back to AR, VR. 3.js is very, very important. It's a 3D graphics library written in JavaScript. It means in your AR application, if you render anything 3D now, then you will be using 3.js. Okay. And see, you can see all these examples, mostly games or marketing materials you can see are just for showcase. They might be creating some scenes like city scenes or car scenes and all. There are many things you can see. And if you already know the Unity, then it's easy actually. There is one, there are many differences I can see Unity, but in these two. Unity is a standalone software. It has its own rendering engine, its own physical engine. It's a kind of package you'll be using. Whatever the functionality you see in Unity is available in JavaScript. That is 3.js. 3.js you can consider as a game engine, but written in JavaScript. It has no IDE. You just need to include the JavaScript file. You write your own coding, same like your HTML web page coding. And apart from these things, whatever the concept you see in Unity, like scene, game objects, components, everything you will be seeing here. The only difference is you won't be seeing any IDE to create it. Okay. And if you go to these fundamentals and all, you can just check on simple 3.js scene here. See, as I said, we have materials, textures, lights, camera, shadows. And what we do in Unity to create a camera, since it's a UI-based software, you just need to right-click on the hierarchy and create a camera. But here, you can create a camera by calling a constructor, or simply you can, I can click it here. See, everything is written in code. You have to write everything in the code. And in Unity, there is a camera component. In that component, you can adjust all those things like perspective, many things. But here you have to write the code by yourself. That's the only difference. But most of the technical words are same, like scene, materials, most of the all
Sir,
are
can
same.
you demonstrate one item and can you show them so that it will be easy for them instead of like explaining?
Yes. Okay. See, this page itself has one simple coding here. They are rendering one cube and sphere. In Unity, we can easily create it here because, as I said, it's a UI-based tool. But here, what we are actually constructing the object. If you check all this JavaScript code, and we are importing the main 3.js file here. As I said, you just need to include this code to get the 3.js functionalities. And again, you need to know JavaScript because they are starting in the main function here. And since you know Unity and C#, this is actually easy. And one important thing, we'll be using HTML canvas component. Without HTML canvas component, you cannot render any web graphics because that is the main tag, HTML tag we use. Okay. Because web is all based about 3 technologies: HTML, CSS, JavaScript here. And see, same like our C#, we construct one object now. What they are doing? Camera, new 3 perspective camera there. See, perspective camera, it's a class. Okay, 3 again is our namespace. This is our namespace, and they are constructing using these 5 parameters: field of view, aspect, near, far. All these are we already declared here. Okay, so if you're coming from Unity, it's very easy, but you have to type it. But again, if you create 1 or 2 projects, will be very easy to understand. Okay, and once the camera is created, we are setting the camera position to here. As we know, X, Y, Z axis, we are setting the camera. And if you go down, and this is a huge JavaScript is going. And we have a cube size of 4, sphere size of 3. Again, as I said, if you know JavaScript, this is all easy. And again, why we are preferring A-frame? That's a very important thing. A-frame, again, you are not going to care about what is 3.js, what is WebGL, nothing. The A-frame gives you the HTML-based tags. That's very, very important. Here, if you want to create a camera, you are writing JavaScript code. No? There, you just need to create one tag, HTML tag. See, for any starters, if they want to create AR or VR experience, instead of going for the low-level coding-based 3.js or WebGL, just prefer A-frame. For a beginner, they won't understand all these codings. But this coding does this simple objects creation. And since we have a camera, we can rotate all these things. And in this page, we have lots of examples like this. It goes like this. And should be knowing HTML, CSS also, so that you can change the position of the elements. I'll come back to our A-frame now. So A-frame. Okay, fine. Yes. First, we'll go to A-frame website. It's a website. And again, saying why we are choosing A-frame. If you want to begin the easy AR development, the best chance is A-frame, because A-frame uses the same HTML coding logic. Whatever you see in HTML, so HTML is very, very easy to learn because it's not something like JavaScript or C# kind of coding logic we have. It's simply tags based. The same tag based approach is what the A-frame gives. I'll give you examples for this right now. And as I said, you don't need to worry about the JavaScript code or WebGL low-level coding. All are tags here. Just go to get started. Yeah. Check this. Again, if you're coming from Unity, this is very simple. It's a normal HTML file. We are creating a scene. Same like in Unity, what we do, we just right click and create a scene. Now, here we have to use a scene tag. The scene tag will create a scene. Inside scene, we'll be adding lots of game objects. Here, they're adding one box. So you can use a box tag to create a box. Using the position attribute, you can set the position. Rotation attribute sets the rotation. Color attribute sets the color. Same goes for sphere, cylinder, plane. And if you run this logic now, you will be getting one scene with all 4 game objects. And with the sky box also, we have a sky. They're setting color for the sky. Now, how to run this code? There are many ways. Just need to copy this. I have a website here. I can show you. Again, the website name is neocities.org. Neocities.org. This again is a free service. I'll tell you how to create all these things. Okay, it is same like how you host your web page. It's very simple, similar to that. So inside, I created A-frames folder here. Inside this folder, I already have one file.
Yeah, there is one more class is going on. Yeah.
Yes.
Can you confirm?
I already have this file, index.html. So what I need to do, I just put the URL here. This is the address and A-frame. That's it. It will open the file. As I said, we have a scene, we have a plane. On the plane, we have 3 game objects, same like Unity, and we have a sky with some color specified. And if you want to check this source code, just right click, inspect. So all these codes you can see, but I'm going to this folder and show you the code. Yes. See, this is the code.
All of you.
Here, how to use A-frame, you just need to include this line in your HTML file. This is the main file responsible to create your AR or VRC JavaScript file. So what A-frame does? A-frame is a framework. A-frame is a framework for 3.js. It means you are not going to see all the 3.js coding. Just use this framework and create whatever you want. When I say framework, it gives lots of easier ways to create AR applications without needing to write the lengthy JavaScript codes. If you still want to write, you should be learning the proper JavaScript logic and going for 3.js. But there are many frameworks available. You can use the framework. Particularly the A-frame framework gives the HTML-based coding logic. It means tag-based. Okay. You can see inside body, A scene tag creates a scene. Then box, sphere, cylinder, plane, A, sky. So all position, rotation, color, and all in HTML they call it as attributes. But again, I have one more technical name for this that we'll be seeing right now here. So again, if you want to run this A-frame based application, there are some conditions actually. The first condition should be you need a web which has this encryption enabled. You need an encrypted website to run this web VR AR experiences. I tell you why the reason. If you see any web VR AR application on your browser, you will be seeing this symbol. This means the site is encrypted. It's very secure. The A-frame actually gives this condition. If you go to this A-frame website, go to hosting and publishing, and they are giving different tools. I'm using this tool, NeoCities. I'll explain that now. And there is one important line here. What they are saying, an important note is that the site should be served with SSL HTTPS. It means it should be encrypted. Because the web VR API or the XR API is a standard. No, the standard says you have to implement the encrypted website to view the VR or AR experience. If you want to know about this more about standard, you just need to type web XR. See, this XR standard maintained by this W3 organization. In this standard, they are saying how to implement the frameworks or libraries for VR and AR. Again, it's mostly JavaScript-based classes you will be seeing here. We don't need to look into this. So just go again back to your A-frame. Yes. For hosting the VR experience, you need the SSL. SSL means you have to purchase your own domain if you want to serious hosting and all for commercial thing. But there are free alternatives. Glitch is an online website where you can host your A-frame based applications. It gives your own some space as well as SSL certification, but it's not completely free. If you want more functionalities, you have to buy it. And if you want easier alternative, then we have a NeoCities. NeoCities is a hosting provider. It gives a free account with 1 GB of storage, and that we can host our website. It's same like hosting your normal website. You just need to upload the HTML file. Inside the HTML file, we'll be having our A-frame coding with all the tags. That coding will does all the job, and rendering will be taken care by your 3.js, and 3.js uses WebGL. It's again, those things are hidden from us because since we are using A-frame, those things are hidden from us. But internally, when you load this A-frame enabled HTML file, the rendering all handled by WebGL. And we'll see 3 examples later now. Before that, as I said, this is an A-frame, as I said, is a framework for JavaScript. Next important thing you want to understand is ECS. A-frame uses ECS. And what is ECS? That's what we have to discuss now. Yes, we'll come back here. ECS is Entity Component System. That's a full form for ECS, Entity Component System. It's just opposite of your object-oriented programming language. It's a kind of bit programming I'm going to explain. So we are all using, if you're using any Unity game engine, all you're using is OOPS paradigm. So you are using object-oriented programming to create any game or application. But nowadays, even Unity is actually changing to ECS. It's not like they are going to abandon OOPS programming completely, but slowly they are changing to ECS. So why people are choosing ECS over OOP? What is the advantage? That's very, very important. And A-frame uses ECS. Once you understand this ECS now, that's the base of the fundamental of the programming in A-frame. Then creating your own applications will be easy, and you'll understand how they are putting the component or systems there. We'll come back to the example later. First, understand what is entity component system. And before that, I'll give one warning. Entities are not classes. So people will think it is same like our object-oriented programming. No. OOP is different. ECS is different. People immediately what they associate entities with classes, components with objects. That is not the case. That's why I'm putting entities are not classes, entities are not objects. It's completely different programming paradigm. So I'll show the examples also for entity. In A-frame, this particular tags creates an entity. This is a tag, and we have to close the tag also. /A entity. This tag creates an entity. Creates an entity. Okay. Again, I'm giving examples. I'm going to relate Unity concepts here. Entity is just nothing a tag. It has no meaning without components. Same like we are creating empty game object in Unity now. If you create an empty game object, it's nothing actually. In Unity by default, you'll get a transform component, but here, if you create entity/entity, it's just an empty object. It does nothing. It means you have to add components so that you will get a complete game object. Same thing we did in Unity now. Just create an empty game object. In that empty game object, you can add camera component, light component, or rigid body component like that. So if you want to create a camera component, there are 2 ways. You can straight away right click on the hierarchy, create camera, or what you can do, first create an empty game object, then attach the required components. Same here, entity means just an empty game object we can consider. Then others are components. We have light component, we have camera component, material, and all are components. I'll be showing components here. If you see this here, see, this is components, A-frame components, same like Unity.
Sir, we cannot see that, sir. We can still see your notepad only.
Oh, you cannot see it?
No.
Just a minute, sorry.
And I request all the other students to get some doubts clarified before sir moving forward. If you have any questions, please unmute yourself and ask your questions, or you can put the questions in the chat. Before
is it visible now?
Yeah, we can see your screensaver, sir.
Is it visible now?
We can see your screensaver.
Yes.
We cannot see
Can you
your
see
A-frame.
Yes, sir.
This screen, A-frame. Okay, fine. As I was saying, like Unity, there are components. My audio is clear now?
Sir, your voice is clear, but your screen is showing just your future is created by what you do today. This is the screen that is visible, but
Desktop screen is
demonstration is not visible.
Now it's visible. I'm actually showing Notepad right now.
No, sir, not yet.
Wait. Is it now? No?
No.
Not visible.
Wait a minute. Give me a minute, I'm checking.
Now it's visible. It is Notepad.
Oh, actually, that's a delay actually.
Okay.
Maybe slow internet connection, I think. Now, can you see this website, A-frame website?
Yes.
Right now?
Yes, sir.
Yes. As I was saying, there are many components, and now I'm showing the Notepad. We were discussing entity component system. Entity, without components, entity is nothing. It's just an empty. Same like our empty game object in Unity. At least in Unity, we had a transform component, but here it's nothing. Only the empty tags will be created. You have to add components to create the complete entity. Suppose if you want a box, you have to give geometry, material, and color, everything you have to give. So there are different components available. That's what I'm showing here in the web screen. Under components, we have animation, background, camera, cursor. There are many components available there. Around 30 components we can see here. Okay. And we were discussing what is ECS and how it is different from OOP. Okay. This is very, very important. Even Unity is going to change to this particular programming paradigm. So this is actually a programming paradigm, same like our OOPs. All comes under programming paradigm, okay? But, and what is system? Entity, we have components, and system, it takes care of all the logic, how the particular component is going to behave in the scene, how it is going to rotate, how it is going to animate, how it is going to, delete itself, like that. There are many systems. I'll give you one simple example here, then you'll understand how we can improve the performance using the ECS paradigm. So now this is the example I'm giving. In OOP, if 100 enemies are there in a scene, 100 objects need to be created and managed in a memory. For example, how do you create an enemy? You need to create one class in C#, correct? From that class, you can inherit, correct? For example, you create an enemy class. From that enemy class, you can create multiple different types of enemy classes, but you have to inherit from the enemy class. Suppose if you have, just imagine 100 enemies is too much, just go for 10 enemies. Then means you should be having 10 different classes that is inheriting from the enemy class. Okay, but if you add more enemies, the code will become longer and it will be difficult to manage the code. And you will be forgetting after some time in which class you implemented, in which concept you implemented. There are many, things are there. That is the OOP. So that you need to use ingredients to create different types of enemies, but you should be having a own enemy class. From that you can integrate. When you run the game, when 100 enemies are created in a scene, then you need to manage 100 objects in the memory. Each and every object having its own space. As I said, in OOPS, class is the blueprint. Every object is independent of other object. It means all the objects will share the same the class attributes and methods, but they are independent of other objects. It means 100 objects will be in the memory and managed in the memory. And you just think about the performance. Even though we are using OOPS till now in our programming, mostly in gaming. I'm not talking about the software development. When it comes to gaming, people nowadays they prefer ECS, and this is the performance hit we are getting here. Even though it works fine internally, it needs more memory, more resources. But when it comes to ECS, as I said, even though there are 100 enemies in the scene, there is an animation system which takes care of the animations. There is a camera system which takes care of the camera. It means they are separating the data from the code logic. If I say in OOPS, in normal OOPS programming, when you create an object, the object will be having properties, methods, correct? Many things. It goes on. Whatever you implement inside a class will be same thing will be in the object. This goes for any number of objects. But in ECS, you have an entity with I'm just giving example. If you have entity with animation and the camera components, or you can put 100 entities with animation camera components. As I said here, the data as well as the logic is actually given inside same object. In object will be storing data as well as the methods. But here I can say like this: EC plus S. Entity component is the data, system is the coding logic. This is the example. 100 entities with animation and camera components. When you run the game, whenever an entity requires a animation, the animation system will take care of it. See, animation system take care of all animation component operations. It means the global system is a global logic. Whenever some component requests it, it will run the particular system. If animation component needs animation, then animation system will run all animations. Means whoever requires the animation system will take care of the animation. And if some entity needs camera access, the camera system will take care of the code logic. So we are not running 100 different systems here. Even though we have 100 entities, we have only one system which takes care of all animation logic, all camera logic. But when it comes to OOPS, if you create 100 enemies, you need 100 objects. Each and every object will be having same method, same properties, but its own data. That is the OOPS now. Even if you get 2 different objects, even though properties and methods are same, but data are different. But here we are separating data plus logic. Logic will be different, data will be different. And you can greatly improve the performance because we are not creating 100 systems here. There is only one system. There are multiple systems. For each and every component, we have appropriate system here. For animation component, we have animation system. Camera component, we have a camera system. Okay. So whenever one entity needs animation, the animation system will take care of the animation. So only one animation system in the game. Only one camera system in the game. Any doubt in this? Hello?
No, we request everyone to unmute yourself and just tell the doubts and
Any
ask
doubt?
your queries. Anything.
So if you have any doubt, please ask me or you put in the chat so that I'll try to reply to you.
Sir, I have one small doubt.
Yes.
Sir, in the above line, you said that you have 100 enemies and they'll be managed by the memory of the server. So, sir, basically they work like prefabs.
Yes. See, prefabs again is a gaming concept. What I'm trying to say here, if you implement one gaming logic in using Whoop, 10 enemies will be having, even though they share the same attack method or same inheritance. If you have an attack method in the parent class, the 10 enemy classes will be inheriting the attack method and doing different types of attacks, correct?
Yes, sir.
So when there are 10 enemies in your game, it means 10 objects, correct? 10 different objects. And each and every object will be having the same method, same properties and variables, but with different data, correct?
Yes, sir.
It means we'll be maintaining, even though they are enemies, we'll be maintaining 10 objects in the memory because OOPS considers each and every object individually, correct? There are independent objects.
Yes, sir.
But in ECS, we are separating the logic from the data. It is the other name for ECS is actually data-driven programming. Data-driven programming. So why they're saying data-driven programming? They're separating the components from the system. It means there are, I'll give one simple example in Unity. You have 100 cubes in your scene, 100 cubes. And you're attaching one rotate script, okay? It means you have to attach the rotate script to all 100 cubes, right?
Yes, sir.
Hello. That's the logic we do in Unity, right? So 100 cubes, if you want to rotate them, you said prefab also same. Each and every prefab is actually coming from the same object, but still you have to attach the script, right?
Yes, sir.
It means the single script is actually copied into 100 objects in the scene, even though they does the same job of rotating the cube. But in ECS, what I'm going to do, I just write one simple line in the system, maybe the rotation system. I'm just giving example, rotation system. I'll just implement the rotation logic here. What will say? Rotate. I'll give whatever you want to give, same like Unity can give. Something I'm giving. To whom you are going to rotate? Rotate components, rotate entities, which has rotation component. It means this system is actually a single system. It is in a global space. Whoever requires the rotation, they can get help from rotation system. It means we are not attaching the rotate script to all 100 cubes. The cubes will be there with the rotation component, that's it. So it means we can create 100 cubes with the rotation component. We are not attaching the rotation script to all components, but there will be a rotation system, a single system in the memory. Whichever entity requires the rotation, they can get help from rotation system. Understand?
Yes, sir.
Same goes for anime. Yes.
There is one more question in chat, sir.
Okay, let me. Chat, where is the chat window? Can you explain example a layman term with oops? Okay, this is a very good question. I'll explain. And who is asking? Anurag. Anurag is asking in very nice question. Like in shooting game, seeing we are shooting bullets. There are hundreds of bullets going towards enemy. Okay, how it is using that concept? Can you explain ECS and OOPS? That he is asking. That I can explain. Yes. Now we'll come back. Just think about a bullet. You can create a prefab, no issues. Sir, prefab. You can create a bullets prefab. Sorry, bullet prefab in Unity. So with all the rigid body or whatever you want, you can create as a prefab. When you shoot, we actually instantiate, right? This is what we do in Unity. Whenever you click trigger, we instantiate our bullet prefab and we'll give the direction. It will go towards direction. When it hits the enemy, using ray casting and all, we do all the stuff like that. But think about, we are creating 100 bullets. For example, if you played COD, we are not showing. It means 10 prefabs, individual prefabs, correct? It is in scene, there are actually 10 individual objects and it has its own coding. And if it has an animation, then you'll be having animation controllers in each and every bullet, correct? So animation is our logic, but animation controller is the system which controls the animation. It means, just imagine Unity, can we just separate this animation controller from bullets? It is a general question I'm asking. Can we separate animation controller from the bullets? No, we have to create animation controller attached to the bullet, then you can assign the animation. It means we are implementing the animation system in each and every bullet. That is unnecessary. That is not necessary. That's what I'm saying. In ECS, even though we have 10 bullets, the 10 bullets will be having in ECS, all 10 bullets or 100 bullets, whatever, will be having animation component. That's it. Animation component. And the animation properties we can specify in what kind of animation you want. Okay. And properties you can say. Properties means the type of animation you want, like rotation and all, you can specify here. But the animation controller won't be there in each and every bullet. There will be an animation system which takes care of all the animations. It means whenever the bullets needs animation, it requires the animation system. The animation system will take care of the actual logic of animating the bullet. Just this is the example. Check in OOPS, all 10 bullets will be having its own animation controller. But in ECS, even though there are 10 bullets in the scene, the 10 bullets will be having only the animation component, not the controller. The controller part will be taken care by the animation system. Same goes for rotation system. There are many systems are there. Okay, if you see this screen here, these are components, right? Animation component, camera, cursor, for each and every, which takes care of all the logic. You got the answer or still confusing? Anyone? Hello?
If anyone have any questions, please put up in the chat or please unmute. Anurag sir, your question is, oh, yes, got that. So he has asked one more question relevant to that.
Yes, but when it comes to apply the action onto the game object, it will map those pointers. Wait a minute. So what is Anurag is asking again? He needs one more doubt. When it comes to apply the action onto the game object, it will map to those pointers, correct? See, actually, the system actually which runs the animation, that's a single system. It's in global scope. It is in global scope. In memory, we'll be having only one animation system which takes care of all the animations. It means if you go to OOPS, in memory, we'll be maintaining 10 animation controllers. Even though bullets are same, the 10 animation controllers will be there in each and every bullet. It is unnecessary. That's what I'm going to try to say. In ECS, the animation controller is the single entity, the single thing, single system in the memory. In the global scope, whoever requests them or the system, it will serve the purpose. Okay. That's what you are asking, Anurag? Or still not clear? You went to too deep. That's good. No issues. You are a gamer then. Very good. Very good. Okay. So why I'm explaining all this in ECS? Because this is what A-frame uses. Not only A-frame, even in Unity, if you want to try, you can try. Please, if you are a serious game programmer, I suggest everyone, please at least try this ECS. Unity ECS package. There is one nice example you can try actually. Okay, there are many. See, that's what I said. The rotation can be done using the normal mono behavior. My screen is visible now. Hello. Hello, my screen is visible or not?
It is visible, sir.
Okay,
we
fine.
can see that in Chrome
Yes,
tabs. Yeah.
This mono behavior you can see now.
Yes.
See, this is the normal way of we are doing. This is a simple rotation script, mono behavior script. And in ECS, they won't be using mono behavior. Mono behavior again is based on object-oriented programming. And mono behavior is the base class Unity, but it is derived from some other parent, maybe component is derived from object. The list goes on. If you go backwards now, but the thing is, as a programmer, you'll be seeing only mono behavior, but there are many parents before mono behavior. And in ECS, you won't be using mono behavior. They are giving script for ECS as well as mono behavior. What they are doing, they are just rotating one simple cube. This is the code we already know. And this script has to be attached with all the cubes in the scene. For example, coins, whatever. You have to attach the, even if you create prefab, if you place 10 prefabs, it means 10 times we attach the script, right? So anyway, the script is attached to the game object. This is the logic. This is what they say in ECS. The system, this is the logic. They are separating the logic from the component. I'll come back to that. This logic we already know. Same way what they are doing in ECS. See, cube is the game object with lots of components. Okay, entity is actually our cube with what are the components we be having? Mesh renderer, a collider. There are many components we can attach to the cube. What we are going to do? Rotate. For that, you have to download this entities package from the package manager. Okay. After that, I'll just go back to the last part, what they are doing. They are just getting the rotation component and transform component from the cube. See, this is very, very simple. This is what I'm saying, rotation system. What is the job of rotation system? It is deriving from component system. The rotation system will listen for the request from whom? Anyone who has the rotation component. What I'm saying, for each rotation component, okay, just run this particular line. It means whoever has the rotation component can request and get this code from this rotation system. It means I'm not going to attach this particular rotation logic to all my cubes. It will be there in my assets folder. Whoever has the rotation component can use the rotation from here. That's it. Okay, and they are giving different ways also. Mostly we'll be using for each loop. This is actually very easy, you will understand, I think. Okay, if you both actually one cube uses mono behavior, one cube uses ECS concept, but results are mostly so. But when you copy the cubes again and again in mono behavior, you will be copying the same script again and again. But in ECS, you are just copying the entity, that is cube, with the components. You are not copying the script. The script is actually called the rotation system. It will be only one copy in the memory. That's it. If you try this now, you'll understand. A very simple example. You can try this. And I suggest you just go with ECS, slowly transition to the ECS. In the same project, you can use both ECS as well as mono behavior. If you want pure ECS, it means only using entities. It means the new game that you're going to develop, you can develop using only ECS. It will be very easy actually. You're not going to copy the logic to all game objects. The logic will be kept in one place. It's only one copy. All the game objects with the particular component can reuse the thing. The main purpose of using ECS, the reuse, code reuse. The same thing they are saying with OOP, but again, when we create object now, those are individual objects. It needs the same code again and again. So you just try this particular thing, then you will understand the difference. Yes. And there is Anurag, yes, there is one nice article in Unity blog. If you search for dots now, there is one nice article. From there, you can start your learning actually. Slowly, there are many documentations available, but this is one nice article you can learn about this thing. Okay, even though we are going to use the C#, but we are just changing the style of coding, the paradigm. Okay. Once people of now, you won't get much, but still you can try Unity. There are Unity for. Okay. So that's it. Once you understand this ECS, then you can create whatever you want in A-frame. All you need to understand is HTML. That's it. My screen is visible now?
Yes, sir. It is
Hello.
Visible, sir.
Yes. So what is A-frame? As I said, A-frame is still uses 3D scenes in 3D and all. But as a user, you are not going to script code. There are small code you write, but not to create the scene. The HTML tags. If you go here, primitives. There's a box primitive creates a box. In Unity, same thing we can do using C# coding, but since we have the hierarchy and all, we won't be creating like that. But here, the only way to create a cube is actually you have to use the A box tag. And A box is an entity. That's a technical name I can say. If you put just A box, it has no meaning actually, correct? If I put A box here, for example, A box / A box. This is an entity with no meaning actually. As I said, entity without component has no meaning. You have to add components. Components in the form of attributes. You can add material first. You give one material, then give size, or you can give position also. Then you geometry. That is the size. Geometry you can give. These are the components. Same, if you see this example, they have a box entity. They call it as primitive. It means it's already there. A box, you can add color component, depth component, height and width components. There are 4 components attached to this particular A box. Same goes for other image, light. And if you want to create a scene, you have to create a scene tag. Inside a scene tag, you can create assets. Same like your Unity. If you are coming from Unity, this is very, very easy. But we are writing the code for each and everything. It is like assets means it's a kind of assets folder. We have to create all our assets here. Means if you are having one image, create an image tag and put it. In Unity, what we do, we just drag and drop the image inside asset. But here, you have to attach the image using the image tag. Again, it's a HTML basic. Okay, these are image attributes. And as I said, we can go for one example here. Building 360 image gallery. And we'll first go for basic scene. Yeah, this simple basic scene you will be getting. There is a skybox, there is a terrain, and there is a box, and there is a pointer. So you first need to add, this is the first thing you want to do, include the A-frame JavaScript file. Without this file, it will be just a normal HTML file. If you include this file, then it becomes a web VR or AR file. This is the first step. Then there is an empty scene inside a body. So if you already know HTML now, then this is very, very easy. There's an empty scene. Same like we are creating now. Whenever we create a scene in Unity, by default you'll be getting 2 game objects, but here that is nothing. It's an empty scene. Once the scene is ready, you can add entities. And entities, you have to add components. Without components, entities are nothing. And they are adding one box entity with color component. A box color is red. And they can add this also fine. They are adding geometry, material. There are many ways. Same like Unity, you can check this coordinate system here. I'll just go to the completed one here. Then you'll understand. A box, position, X, Y, Z, rotation, X, Y, Z, scale, X, Y, Z. And there is a sphere they want. The sphere is inside box. Just check where is the sphere. It is inside the box. And again, I'll go back here. This is the coding. You just need to copy paste this coding. Then you will get this particular thing. The thing is, as I said, you can create this website in NeoCities. I'll come back. It's a free website you can create, then copy paste your coding. And if you want computer, then there are 2 that also I'll tell you after this concept. Again, yes. And if you go for 360 gallery now, what you need for 360 gallery, you need images. All those images should be stored in assets folder now. Same like in Unity, what they're doing. First, they are creating a scene. Inside scene, they are creating assets. Inside assets, they are storing all the images like this. All the images are stored. Once the image is stored, they are setting the skybox. Then this link they are creating. It's just empty. No link is here. Then they are creating a cursor. And cursor should be inside camera. And what is the animation the cursor want? These are animation components. Click animation, click reset animation, and fusing animation. And they are giving different properties for all these. What is the effect you want? Easing effect you want. Once this is done, as I said now, this is a cursor is an entity. These are all components. And there is an animation system which takes care of all the animations. And if you copy the completed code here now, you will get a 360 gallery. Again. So to start with A-frame, first thing you want to do is learn the HTML because it's all based on HTML thing and CSS. Then finally, JavaScript. And even Minecraft demo also it's here. These are very simple codings. And if you are building for one VR headset, then you need to implement the controls, VR controls. For VR controls, they have a component. See, they have Daydream. Daydream means Google's develop for Daydream. HTC Vive or Oculus. One example here.
Hi, sir.
VR controls.
Sorry to interrupt. Sir, can you hear me?
Yes, yes.
Sir, can you take one small example in the A-frame and can you demonstrate from the scratch and show the people, students here to understand the flow of it? Can you take any simple demonstration?
Yes, I'll show.
Because we are instead of going through all the components, I think these 2 hours will not be enough for going through all the components. But if they can at least go through a simple demonstration process, at least they can understand some simple concepts.
that if you are building for gear VR headset, then you have to include this one. All our components here. And there will be one controller. If you check this HTML code, yes, all the tag based. So we'll be using this image tag.
Sir, your voice is not clear, sir.
Whenever you want to A-frame, then go with HTML.
Sir, your voice is not clear.
First, but there
It's
are
breaking.
many alternatives.
Hello? Hello? Yes, sir. Sir, you are not audible actually.
I don't know what is the issue. Hello? Sorry, not coming. Hello.
Yes.
Sir, is it audible now?
Yes, sir. Now audible.
Okay, fine.
That's fine. Yeah.
And if you want to start with other web AR softwares, the best example is there is 8th Wall, but it is not free. 8th Wall, again, even they say new product names. Internally, they'll be using this JavaScript libraries and WebGL to render all these things. And it's very, very popular and mostly used web AR SDK, this one. And previously they were giving for Unity, but nowadays they changed the policy, I think. It's they have their own cloud-based tool here. You can develop the AR application in the browser itself. There is a 14-day trial if you want to try. There is a 14-day trial. And again, if you know JavaScript, it'll be easy to understand and develop the applications here. It is not like A-frame. A-frame uses HTML tags style, but here it uses the pure JavaScript coding. For example, I can choose anything like this. Codings are there. Again, this it is for people who understand. These are alternatives for 8th. Wall. There are many things, but this is very, very popular. Now, as I said, we'll just go back to one small example. Yes, I can show you this example again taken from your A-frame website. Okay. My voice is clear?
Yes, sir. It's clear.
Hello. Yeah, because internet issues, it's coming and going. Okay, fine. See, before I give you example, I just go back to hosting, how to host the application. Let's copy this. Yeah. See, as I said, you need a SSL, that is encrypted website, to display all your AR or VR experiences. And the A-frame website gives suggestions, glitch you can use. Okay. You can use glitch. or you can use NeoCities, or you can use your own domain. It means you have to purchase one domain from GoDaddy or any other provider, but make sure you have SSL support, because GoDaddy by default, they won't give SSL support for free. But if you go for Blue Ghosting, they'll give SSL support. So you need SSL, it means or encrypted support to run your A-frame code. Not only A-frame, any other web AR experience needs encrypted site. Okay, I will come back to this. So NeoCities, you just need to create a simple account, that's it. You can create your own subdomain here. For example, you can give your name and fill necessary details, then create it. Once you create your account, you can log in and you'll get this window. You'll get a dashboard. You'll go to dashboard. You will get this kind of login. Once you log in, you'll get this kind of do. There we have a file manager. Same like your Windows, you can manage your files. This is same like hosting your website. By default, you'll be getting index.html. You can create your own folder. Inside folder, you can host all your website files. So I have index.html here. That's what I'm going to show you now. So I suggest you can choose both tools, Glitch as well as this one. Glitch also is nice, actually, gives lots of support. Or you can go for NeoCities. If you don't want both, you can create your own domain, purchase it, and make sure it has SSL support and upload. And there are many free services available, but don't go for free services. It will be very slow. If you are going for serious deployment, if you just want test, then you can go for free alternatives. I prefer NeoCities because it has a good support as well as kind of fast, actually. I have index.html. See, I just copy pasted, nothing, just copy pasted the code from here. We already saw this scene, box, sphere, and all. What I can do, just save this. If you see this is the output from the file. We can change this, actually. What I'm going to change the color of the sky. It means just go back to the file. Sky means the sky box, same like our Unity. Change this color. Maybe I want black. So 0, 0, 0, 0, 0. In 630 also fine. Save this. Now go to website and refresh. It will be getting the black color. Now, if you want to add one more object, for example, you want to add one more cylinder here. You just copy paste the cylinder. Change the position X, I want 4. Y, I want 2. Z, keep it because the camera is actually in the back side. Z, no need to change. Radius, I can give 1. Height, I can go for 2. And color, you can change the color to red. Red means FF00. That's it. Save it. Now, file's saved. Just go back and refresh. See, now I have a cube. But this is Unity. We could have easily achieved this by just dragging and dropping, right click and all. But here you have to write the code. But it will be very easy, actually. Once you start creating now, it will be very easy. And if you want this teleporting and all, that someone is asking, in Unity, we have to create this rigid body. We have to attach to the rigid body character controller. Then when you press the keyboard, it is Lumina. But here it's very easy, actually. I'll come back to that. Before, I'll just explain this one. Same like Unity, we have raycaster. You already know what the raycaster does. And we have rotation. We have renderer component. That's very, very important component, renderer. Okay. You can check all this. Sound is there. Same like Unity. Now, if you want teleporting and all, I just show you one simple example here. Minecraft demo. This is what I wanted to show you. We can view the demo right now here. The demo is hosted in Glitch actually. Yeah. And if you open this in your mobile phone, you can insert the mobile phone inside one VR controller. See, they have a simple for this VR. It means you can open the same website in Vive or Oculus Go, or open in phone and insert the phone to any controller. If it permits. For example, Google Cardboard, we can insert the phone actually. If I click VR now, it goes to VR mode. Right now, I don't have that one. Simply, I check in the browser. See, you have to use the keyboard and moving. And click wherever you want, you can click, you'll get the, like this. And if you want to create this in Unity, obviously we have to write coding for this one, and the coding to move, rotation, all these things we have to write coding. And we have to implement this random cube with different colors, right? But this coding is very simple. Using this as a template, you can create your own simple game, like create environments, buildings, go inside buildings, interact with the object, like that you can create. Kind of interior walkthrough you can do, because all these codes are here. You just need to place the buildings in the thing. And if you want to build place buildings, and there's a separate format that you have to follow, not FBX or object. They have a separate format for that. That first you have to convert to that format. And so what you have to do, I can explain this all code, but I'll give only this one. So inside scene, see they are storing the ground texture. They are creating one cylinder object. That is our actually something. And they're adding a background. It's a simple thing. If you go now, step by step, they are saying they're adding sky means background. It means they're just taking the sky texture and applying it to the sky. And for the click to whenever you click, some cube is applying, that is actually logic. For that you have to write JavaScript code. That is no other way, because all this design part you can do with the tags. For logics like moving and clicking, there should be some JavaScript logic that's also given here. This is the complete. We cannot see right now. To any VR here. Time we can actually edit this movement coding, place buildings, do our own interior walkthrough. So, any doubt regarding this A-frame? You can ask me right now. Hello. People? Hello.
Yes, sir. Tell me. Tell us, sir.
If you have no doubt, you can leave the session.
Guys, any doubts? Anything you
Yeah,
want
any
to
doubt
ask?
regarding this A-frame, today's session? Hello.
I think the one is answering. So let's consider that they don't have any doubts. So dear faculties, anyone have any doubts like Anurag sir, Prabhakar sir? You want to raise any
Yeah,
question
only Anurag asked a few doubts.
Afra? Yes, Afra, you can have this recording shortly. Samuel sir will be sharing you the recording. So anyone else?
No, Ajay sir, no doubt so far. It's been really great, Thank you.
Okay. Thank you, sir. Thank you for the session, sir. Thank you.